All right, so now we're talking about a couple of different special cases of factoring that you're going to see. The main one, and this is the one I want you to focus on the most, is this thing called a difference of squares. Okay, so if you see this word difference, that means subtraction. And squares are numbers that you can take the square root of and get a whole number. So like 64 is a square because it's equal to 8 times 8. So I multiply a number by itself and I get 64. So 64 is considered a square. All right, so numbers like 1, 49, 36, 81, a whole bunch of numbers, these are squares. All right, so before we get into the actual factoring part, I want to go back to distribution for just a second. So we're going to distribute here. X times x, x times negative 4, 4 times x, 4 times negative x. And what happens is these two middle terms are going to cancel. And so you're left with x squared minus 16. All right, now the difference, remember subtraction. And then 16 is a square because the square root of 16 is 4. X squared is a square because the square root of x squared is x. So literally a difference of two squares. You always want to check for a GCF before you do anything, but the general pattern of difference of squares is where you get your conjugates. Take the square root of a squared, which is a, square root of b squared, which is b. You add them, subtract them. Okay, so looking at example 1, this is a squared minus 4. Okay, now just so that you are on the same page, even exponents are squares. Okay, so that's why a squared would be a square. Okay, we've got a difference, even exponent. 4 is a square. This is a difference of squares. So the square root of a squared is a. Square root of 4 is 2. Those roots, add and subtract. Okay, we've got a difference, subtraction. 81 is a square. I've got my even exponent, x squared is a square. Now, if that x squared has a number in front of it, it also has to be a square. So like if I all of a sudden put a 2 in front of here, it stops being a square. All right, so square root of 81 is 9. Square root of x squared is x. You keep the order. 9 minus x. GCF, big time on this one. Right now, all I have is that it's a difference. Okay, because I have odd exponents here. It's not a square yet. But I can also divide out of 4. Okay, they have a variable in common, so x. It's going to be 25 x squared minus 9. Okay, and then what I have left, there's my difference. We know 9 is a square, square root is 3. Then we're looking at this. That's a square. X squared is a square. So the square root of 25x squared, square root of 25 is 5, x squared is x, and the square root of 9 is 3. Keep that order. So 5x plus 3 minus 3, and you need to bring down that 4x. Okay, example 5, that's addition. We need subtraction. So since I don't have subtraction, this is not a difference of squares. Okay, so we're going to call this prime. All right, so there's my difference, subtraction. 4 is a square, 49 is a square. X's exponent is even, and Y's exponent is even. So I've got a difference of squares here. So the square root 4x squared and the square root of 49y squared. Add the root. Subtract the roots. All right, GCF looks like it's going to be 5y, or 5xy, excuse me, because they have x's and they both have y's. X squared minus 25y squared. Okay, now I'm not going to write it this time, but there's my subtraction. X squared, even exponent, 25 y squared. So square root of x squared is x, 25y squared, 5y. Add, subtract, and bring down your 5xy. Okay, subtraction. 1 is a square. X squared, both have even exponents. Difference of squares. So square root of x squared, y squared is xy. Square root of 1 is 1. Subtraction. X squared, even exponent. 4, that's square. Y squared, even exponent. But I want you to highlight the 5. 5 is not a square. Not a perfect square, at least. Okay, I can't take the square root of it and get a nice, pretty number. So this is not a difference of squares. So it's prime. Right, take the GCF out here, and that's 2. Subtraction. 36 is a square. Square root is 6. And that n has an even exponent. It's 4. So this is a difference of squares. The square root of n to the 4th. To take the square root of an exponent, you divide it by 2. So 4 divided by 2 is 2. And then the square root of 36. Add the roots. Subtract the roots. And don't forget your original GCF. Looks like it's 8y. Yeah, 8y. X squared minus 4y squared. Subtraction. X squared, even exponent. 4 is a square. Y squared with an even exponent. So square root x squared. Square root 4y squared. Add. Subtract. And original GCF. Okay, m cubed n. So they both share an m and an n. N squared. Now remember, when you factor out an mn out of an mn, that's 1. Difference, even exponent, square. Square root of m squared equals m. Square root of 1 is 1. So m plus 1, m minus 1, and your original GCF. Okay, now I'm not likely going to give you anything that's this, probably not going to give you anything like this on your test. I'm just doing basic factoring and your difference of squares because that's the most important part. This is helpful but not necessary, okay? So a perfect square trinomial. Okay, if I have x plus 4 squared, that really means x plus 4 times x plus 4. Okay, and I want you to pay attention to this, okay? Because that looks really a lot like that, right? So we're going to do x times x times 4, 4 times x, and 4 times 4. Okay, now look here. A squared, b squared. A squared, b squared. And then we combine our like terms. And we end up with double, because I have 2 of them, a times b. Again, I'm so not concerned about this. I'm only going to do a few of these because you can factor like normal. Your leading coefficient here is 1. Just make sure your leading coefficient is a positive 1, which means I can look at the 36, factor pairs of 36 that add to be negative 12. That's 2 and 18. So it's going to be 6 and 6. Okay, so they have to multiply to 36, but add to that negative 12. So that's a negative positive, so double negative. And there's your factor pair. Okay, and since your leading coefficient is a 1, not like a 2 or a 7, we can go right to our factor pairs, y minus 6, y minus 6, which you can rewrite because there's 2 of them, y minus 6 squared. Okay, so you can see there's your a, there's your b. So a squared, b squared, double the product. 6 times y is 6y times 2 is 12. Again, not particularly worried about it. Because we can get some really psycho ones. We're not going to do that one. But not necessary. All right, so we have x squared plus 8x plus 12. We want to make sure that leading coefficient is a positive 1. It is. So we can go right here. 1 and 12, 2 and 6, 3 and 4. So it's got to multiply to 12, but add to 8. So all positive, so I don't have to worry about that. So that's 2 and 6. Since that leading coefficient is a positive 1, I can go right to my factor pairs. So this is not a perfect square trinomial because I don't have a repeating factor. Okay. Leading coefficient on example 3 is 25. I don't have any GCFs. This is 25, 10, and 1. So multiply the leading coefficient by the constant. Factor pairs. Everything's positive, so we leave everything positive. So because that leading coefficient is a 25, not a 1, it's got to multiply to AC, so that's your 25, and add to 10. So that's going to be 5 and 5, and that's when we break it. Bring down your 1, 25x squared. Group the first 2 terms and the last 2 terms. GCF for the first one, 5x. So 25x squared by 5x is 5x. 5x by 5x is 1. And I mentioned on the 6-3 video, if you do not have a GCF, it's always 1 or negative 1, depending on the sign. No GCF, positive sign, so positive 1. Common binomial factor. Whatever is left, and that is a repeated factor. Okay, again, the other way you could do this, if I take the square root of 25x squared, then the square root of 1. Okay, if I multiply them together and double it, do I get the middle term? Yes. And since it's an addition sign, 5x plus 1 squared. I'm going to do this one with the pattern. I'm going to take that, no GCF, because it's 64, 16, and 1. I'm going to take the square root of that first term. So that's going to be 8x. Then I'm going to take the square root of the last term. If I take those two terms, multiply them together, and double it, do I get the middle one? 8x times 1 times 2 is 16x. All right, so we take that sign in the middle. And we take their roots, 8x and 1, square them. Where this comes in handy is problems like this one. So I'm going to take the square root of the 36x squared square root of 25y squared. If I take 6x times 5y and double it, do I get 60xy? So 6 times 5 is 30, times 2 is 60, x times y, xy. So I do. So I'm going to take that, it's going to go with my sign in the middle. Root 1, root 2, squared. Take the GCF out. Okay. Take the root. And that one. So if I take the 5x and the 1, multiply them together, and double it, I get 10x. So that sign goes in the middle. Root 1, root 2, squared, original GCF. Okay. If I don't get double, then I got to factor it a different way. We did this earlier, factoring by grouping, sort of common binomial factor. It's going to bother me. Common binomial factor is at x minus 3. Whatever's left is your other one. So if we're factoring using those, factoring by grouping, then you want to make sure your first two terms have a GCF. Okay, if you have to rearrange it, do that. But the first two terms have to have a GCF. So in example 1, I'm looking at this first two terms. They do have a GCF. So we'll group the first two and the last two. So group 1, group 2. GCF of the first group is x. So 2x squared by x and 3x by x. Second group, plus sign, because of the plus sign. And its GCF is 3. So 6x by 3 is 2x, 9 by 3 is 3. Common binomial. And whatever is left. First two terms are factors, have a GCF, so first two and last two. Group 1, group 2. GCF of that first group, x. 6x squared by 3x is 2x. Negative 15x by 3x is negative 5. GCF of the second group would be positive 2. 4x by 2 is 2x. Negative 10 by 2, negative 5. Common binomial. And whatever is left. Those first two terms have a GCF? You do. 4. Group first 2 and last 2. Group 1, group 2. That's 4, so that is x plus 2y. Okay, a little less obvious on this one. That GCF is a. X plus 2y. Common binomial. Whatever is left. Okay. Group first 2 and last 2, and I can do that because it already has a GCF. Group 1. 2. For whatever reason, I just paused my video, but it's fine. GCF of the first group is second group, you have that minus on, so I want to bring that down, and that's 2. So positive 2x, positive 5. Common binomial. And whatever is left. All right, so you want to make sure that your first 2 terms have a GCF. In this case, they don't. So you can rearrange it however you want to, okay? It doesn't matter. So the immediate thing I see is if I switch these 2, then my first 2 terms will have a GCF. All I'm doing is switching their places. First 2, last 2. Group 1. Group 2. GCF of that group. Put 8 and 2 and 4a minus 3b. Second group, 21 and 8 is 7, and they have a c in common. So that is 3b minus 4a. Okay, so what you should see right here, and this is kind of trippy, they're almost the same. All right, so I'm going to take this one, I'm going to flip it around. And I'm also going to factor out a negative 1. So if I factor out a negative 1, negative 4a becomes positive, positive 3b becomes negative. But I also have the 7c, so it's going to make it negative 7c, 4a minus 3b. Now I have a common factor. So 4a 2d minus 7c. Minus from there. All right, rearrange so you have proper order. Just so the first 2 terms have a GCF. Because right now 6a squared and 5bc don't have any. Group. Group 1. Group 2. GCF of the first group. Second group. Okay, so they are almost the same. What's working out in our favor is that everything is positive. That's positive 3a, that's positive 3a. Positive 5b, positive 5b. So if I just rearrange the order, keep the sign, I'm going to end up with the same thing. I just switched these places because the order, the only thing that was different was the order, not the signs. So common binomial factor. And whatever is left.